Okay, so my friend told me that knowing calculus is not going to help me beat him on the AMC 10 because, you don't need calculus for the exam. Very funny. You don't, obviously, because it's the AMC 10. They're not expecting students to know calculus. But he thought it wouldn't help me beat him. I don't know what place he got, but it certainly wasn't above first place. Now, can I prove that the deciding factor was me knowing calculus? No, it definitely wasn't, but still got to throw it in his face. Now, I'm not going to tell you who this was, but I'll give you a hint. His name started with an A, and he's Indian. Now, you might be thinking that gives it away. That's half my friend group. So. We are told that the line f of x equals 1/3 x plus 1 divides the square region defined by 0 less than or equal to x less than or equal to 2 and 0 less than or equal to y less than or equal to 2 into an upper and lower region. The line x equals a divides the lower region into two parts with equal area. Then a can be written as square root s minus t. Find f evaluated at t. Okay, so how can we approach this? Well, I think naturally we're given all this upper, lower regions, like boxes and stuff. So I think obviously the first thing we want to do is sketch the scenario, just naturally. Okay, so let's just say right here is 2 on the y-axis, which means this is about 2 on the x-axis. And we know that this is our bounded region. That's not really a square, but it'll be good enough. We know that this function, this line, will divide it, but we can see that our y-intercept right here is going to be 1, which means the line in this quadrant will start halfway, and then we can just guess that it looks something like that. And so we know that we have our lower and upper region, and we know that this region is divided into two parts with equal area by some line x equals a. And we'll just go ahead and say this right here is a. Now, we don't know what this is, but this is just for the purpose of our diagram. Now, we have our two areas right here, and we know that area 1 is going to be equal to area 2. Now, obviously, the next thing we want to do is find the area of this lower region. Now, we could do trapezoid formulas, but I'm just going to, since the theme of this is that I used calculus to shortcut it, I'm going to just integrate. Even though this takes about the same amount of time, since the shortcut later is calculus, I just thought I'd integrate. So this is going to be equal to the integral from 0 to 2, 1/3 times that of x with respect to x, plus integral 0 to 2 of integral 1 dx, and this is going to be equal to x squared over 6 evaluated from 0 to 2 plus x evaluated from 0 to 2. And down here, you can plug in 2. And this is going to be equal to 4 minus 0, so over 6, so 4/6. Plus, this is just, we don't need to worry about this, so 2, and then we can convert that to 6, so 12 over 6. We get 16/6, or 8/3. So we know that area 1 plus area 2 equals 8/3, but area 1 is equal to area 2, so 2 area 1 equals 8/3, and so area 1 is going to be equal to 4/3, and that's going to be equal to area 2. So now we want to find the line x equals a that actually makes these two areas equal. Well, let's think about this for a second. That a must satisfy this property. The integral from 0 to a of 1/3 x plus 1 dx must be equal to 4/3. Because the area from 0 to a under this curve is just going to be area 1 right here. And we know what the value of area 1 is, so we can actually integrate this out. But now we have a variable here and a constant here, so we're actually going to be solving an equation. So again, we can just remember from earlier that these integrals right here are going to be x squared over 6, and this is going to be from 0 to a and then plus x from 0 to a. This is going to be equal to 4/3. So now we can plug in. And now we get a squared over 6 plus a minus 4/3 is going to be equal to 0. And we can multiply everything here by 6, everything. So that gives us a squared plus 6a, and then minus 4 over 6, so that's going to be 24 over 3, so minus 8 is going to be equal to 0. We can use the quadratic formula. So we get negative b, which is 6, plus or minus the square root of 6 squared, which is going to be 36, minus 4 times 1 times negative 8, divided by 2 times 1. This is going to be equal to negative 6, plus minus square root of, this is going to be negative 4 times negative 8, which is going to be equal to 32. So 36 plus 32, which is going to be 68, divided by 2. Now we'll go ahead and bring this right here. And let's go ahead and look at the square root right here. Keep in mind that 68 is equal to 17 times 4. I know that's a little bit weird. That might not jump out to you immediately, but I'll show you right here. So yeah, it's absolutely equal to 68. I didn't see that initially on the test, so I had to actually divide out, which is really pathetic for an AMC winner. But yeah, for some reason, this feels like 17 should not go into it. I don't know. It's weird. Anyway, this is going to be the same thing as negative 6. And since it's 4 times 17, this is going to be the same thing as plus or minus 2 square root 17. We're dividing that by 2. And then we can actually factor the top. We'll do 2 times negative 3 plus or minus root 17 over 2. This cancels. Now we get that a equals negative 3 plus or minus square root 17. Now this is close to our desired form, except we have this plus or minus. But since we know a needs to be in this quadrant, we know that a must be positive. So we can completely obliterate this solution as it is extraneous. And then we can actually just rearrange this as root 17 minus 3. Now this matches our square root s minus t. So from here we get that s equals 17 and t equals 3. And our original question was to find the function of x evaluated at t. So what we can do is we can plug in to f of x, f of t, and we can make sure that we write it as f of 3 because we just found the value of t. And we're going to get 1/3 times 3 plus 1. 1/3 times 3 is just going to equal to 1, so our answer is 2. F of t is going to be equal to 2. And this is our final answer. Now, the original problem actually had the final thing as what is s plus t, but I saw this function and I'm like, oh, come on, let's just replace the y that was there and make it f of x and then have you evaluate the function of x at t. It just seemed like a more satisfying conclusion to our problem. Anyway, thank you for watching. I'm very happy about this. Not trying to brag, just happy about it. So thanks for watching.